Hey, I wanted to talk about electron orbitals. Okay. Um, there's the picture everyone knows of an atom where you've got the nucleus and these little balls that spin around it at regular intervals, which are the electrons. And they go around in this kind of spiral pattern, maybe. Or and then there's the more erudite picture of you got this little speck in the middle, and then it's a blur. It's a probability distribution. The electron is sort of anywhere within the right distance from the nucleus at a time. So obviously this looks a lot similar to quite a few of the different topics I've got going on in my mathematics. And I've always imagined this being like, imagine if the electron were going faster than the speed of light, and then you could only take pictures of it up here with a speed of light shaped camera, and wow, where all of the frequencies of everything you've got going on is going to be faster than the or slower than the frequency of the speed of light. And whenever you take a picture of this electron, you should never be able to get it on a direct multiple of its period. You should never be able to catch the same thing twice in the same part of its period, and so you would see what we see of you're never allowed to know precisely where the electron has been if you know where it is. Okay, now it doesn't have to be going faster than the speed of light. It can be going the same as the speed of light, but through a pi dimension or a pi curve that instead of doing what light might do in that same situation, which would be imagine to make a light ring that just keeps going around and going around. It can't do that because when light goes on top of itself, that gets heavy. There's more information going on than just light can hold by itself, because as soon as light holds any information at all, it's not going at the speed of light. It's a tiny bit heavy. So instead, that thing that looked like light now becomes an electron and gets forced out from its kind of laminar flow to its turbulent flow state, and now it's all about doing 90 degrees everywhere. And you find that this bit we've got a thing that we can point at, and it's spinning, and it's also got a graph that it's formulating, which say isn't spinning, and that you combine the graph of the spinning thing with the graph of the orbital path, and that should add up precisely to what was in the light, which is electromagnetism, electricity and magnetism. My view of the atom is much more simplistic than the rest of science. Let's keep going. We have I mean, like people who actually know their stuff. That's what I mean. The whoosh, 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 it goes around in an orbit. I don't think that's all one step. I think if light is ever convinced to go in a tight enough circle, imagine if you had a container full of light and the light is going in all the directions it could possibly can and tracing out all the routes it possibly can, and then it just does the tightest circle that you can imagine with a little hole in it. And time didn't move for light all the time that it went around. And so you've got this little guy who, above and below him, time seemed to move, but all around him, time didn't seem to move. So what else is he doing but spinning? Maybe something like that. And I think once he's spinning, and now there's this dimension of spin that whilst roots are being carved out and paths are being formed, you got this other dimension of spinning, and that can affect, and it will affect all of the routes that can be made. It means that some of the routes are going to be way more likely, and some of the routes are all going to be profoundly many of the routes are all going to be squished out at once or like filtered out at once. You can't go that way because your thing is spinning. From there, you can think that light was relatively 2D in relation to the little guy who got surrounded by light and time was all around him. Um, or her. And then you got this thing spinning, but it's still spinning in this big space. For some reason, now it is. Now we've got one little thing spinning that this whole other dimension makes sense to talk about. Oh, because it has become dimensionally unbound by learning how to spin. There's one dimension that has been negated by surrounding it in light, and there's one. Right, so it has just another free access because we unbound it from an axis. We forced it to forget everything that was going on in that lateral dimension, and so we imagine it just starts spinning with the kind of spin that you can't slow down because it hasn't sped up to anything. This is just the error 404 of momentum. And now, manifestly, there was a way that everything nearby it had in common about its trajectory. Everything did know what was happening in that 2D plane, but now it doesn't. Oh, this one doesn't. And so this one's allowed to defy everything that's around it, and so that's going to look like it has another free dimension to play around in. Seems good. In that free dimension, if the electron can ever trace out that path where it bumps itself right on the butt, then you have an atom, and it has this consequence that there's a bit of space that's twisted up by this electronic vortex. The potential in the space that it surrounds is all affected by this thing sort of at once. It has this twist, and you've got the proton, and I think the neutron has a perpendicular charge to it. But then with the don't do this to me. Then the outside charge negates the inside charge of the proton, but then what about the neutron? Doesn't that have to be neutral? Maybe it's like that's cancelled out by the time dimension thing. That sort of makes sense, as the neutron is particularly implicated in radioactive phenomena. I think that, well, if you have two neutrons, oh, well, that's a good question. You can have an atom with two neutrons in it, like deuterium. And what then? And it's more radioactive. Why? Because it's pulling against the future more? A lot more? Twice as much? And what? You're trying to like pull the mass through time that's only so dense, and it just wriggles a lot. Do I think that neutrons by themselves ping off quickened time? Feels like they could be dark matter. I'm suspicious that we don't see protons by themselves ever in nature. We can pull them out of an atom. Or if things are radioactive, sometimes they emit protons by themselves. So what does that suggest to us? Well, that the space already has the capacity for protons in it. And then a special kind of wiggle can make protons that gives us a better evidence of why the spinny thing happens. Oh, and we had stuff about the edges of the circles and quarks. If I choose 2 points from the edge of it, or if I choose the 3 most extreme points from a circle, I've always got like 1 up and 2 down, or 2 down and 1 up. Is that it? Well, and those points have these very extra special relationships that we're about not being able to tell the difference between curves and lines for a start, and not really have distances. Is that the maths, when you zoom in, has a model of this thing that science is just bound out to talk about? It does sort of make sense. Are we still interested in a Hilbert machine? Yeah. What you got to do to make a Hilbert machine? The inline logic thing. Yeah, so do the inline logic thing. Okay. I could start typing at that now. Cool. Bye. Peace.